Welcome to Angle Relationships, Part 2. A line that intersects two other lines in different points is called a transversal. So here's two lines, A and B, and they're going to be crossed by another line, T. T is a transversal. It intersects the two other lines at different points. In this diagram, how many angles are formed? And I would say there are 8. There's 1, 2, 3, 4, 5, 6, 7, 8 angles are formed by these 3 lines. And they have many different kinds of relationships. Today we're going to get into some more of those relationships. The first relationship that we're going to talk about is corresponding angles. Corresponding angles lie on the same side of the transversal and in the same relative position. So here's a map of corresponding angles. Angle 1 is in the same relative position as 5, right? They're both in the top left corner of their group. And then angle 2 corresponds to angle 6, angle 3 and angle 7, angle 4 and angle 8. Those are called corresponding angles because they're in the same relative position of their grouping of angles, right? We have one grouping of angles on top right here, and then another grouping of angles on the bottom down here, and the ones that are matching are in the same relative position of their group. So angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8 are corresponding angles. All right, moving on. If the transversal is crossing parallel lines, then the corresponding angles are congruent. That means they have equal measure. So if line A is parallel to line B, then we find that the measure of angle 1 is equal to the measure of angle 5, and the measure of angle 2 is equal to the measure of 6, 3 and 7 have the same measure, and 4 and 8 also have the same measure. Again, that M in front of the angle symbol means that it's the measure of angle 1. The next relationship we're going to talk about is alternate interior angles. Alternate interior angles are in the interior of a pair of lines and on opposite sides of the transversal. So first of all, we want to talk about interior and exterior. And for me, I always think of paint. When you paint the outside of your house, you use exterior paint. And it's usually an oil-based paint, and it's very durable, right? It can stand up to the sun and the rain. When you paint the inside of your house, you use an interior paint. The interior is inside. And that kind of paint is usually less toxic and hopefully has less chemicals in it because we're breathing in the gas, the off gases from that paint. And so exterior paint, exterior means the outside. So this area and this area are both exterior, whereas the interior is between the lines. It's on the inside. So alternate interior angles have to be in the interior region, and they have to be on opposite sides of the transversal. So angle 4 and angle 6 are on opposite sides of the transversal in the interior, and so are 3 and 5. So those are our two pairs of alternate interior angles. Angle 4 and angle 6, and angle 3 and angle 5 are two pairs of alternate interior angles. And again, if the lines A and B are parallel, then those alternate interior angles will have the same measure. So the measure of angle 4 will be equal to the measure of angle 6, and the measure of angle 3 will equal the measure of angle 5. So here's a problem for you to try on your own. If the measure of angle 1 is 145 degrees, find the measure of all the other angles. Please pause the video, try this problem, and then check in for the answer. we're going to find that the measure of angle 2 is 35 degrees because 1 and 2 are a supplementary pair. They create a straight line, so you can subtract. And once we know 1 and 2, the rest is child's play. We're going to have 3 is a vertical angle to angle 1. Angle 4 is a vertical angle to angle 2. And then 5, 6, 7, and 8 all correspond to one of the first 4. So 5 corresponds to 1, 6 corresponds to 2, 7 corresponds to 3, and 8 corresponds to 4. And we get that there's really just 2 different measures that make up all 8 of the angles. 35 degrees for the acute angles and 145 for the obtuse angles. This type of problem is one that we can set up an equation for. So we want to find the measure of angle 1 and the measure of angle 2 if we know that the angles marked measure x degrees and x plus 90. So what do we know about the ones that measure x and x plus 90? We know that they correspond to one another, therefore they're going to be equal. So we're going to get an equation for x equals x plus 90. And now it's very similar to those equations we've solved where the variable is on both sides. So we want to subtract the smaller coefficient. What's smaller, 1 or 4? 1 is smaller. So we subtract x from both sides. Now we get that 3x equals 90. If we divide by 3, we're going to get x equals 30. So x equals 30. This is not the answer to the question, however. The question is, what's the measure of angle 1 and the measure of angle 2? Well, this angle, the 4x, is going to be 4 times 30. That's 120 degrees. And this angle is x plus 90. That's 90 plus 30. That's also 120 because they correspond to each other. They both equal 120 degrees. The angles we're looking for are the supplements of that. So we're going to have 180 minus 120 equals 60 degrees. Angle 2 corresponds to angle 1. It also measures 60 degrees.